So today I'm talking about open data sharing for Earth observation satellites. And to start out the talk, I want to talk about why I focused on that as an issue. So there are two parts to this. First, there are a lot of Earth observation satellites out there. So there are more than 35 nations that have been involved in the operation or ownership of an Earth observation satellite. And we've had close to 500 Earth observation satellites, civil government satellites that have been launched since the beginning of the space age. So with all of those countries involved, all of those satellites, we've collected a lot of data. And that data is what is really valuable about the satellite, right? So all of the applications, all of the scientific knowledge that we gain, all come from the satellite data. And yet, less than half of all Earth observation satellite data is made openly available. So this data, most of it is restricted in some way. Either there's a price on the data or a process to get access to the data, so it's not just openly available. And this is even more surprising when you consider that there are a number of international organizations that really focus on encouraging data sharing. So there's the Group on Earth Observations, that has really tried to get nations together to emphasize the importance of sharing Earth observation data, and also the World Meteorological Organization, so the group that works with lots of different weather agencies all over the world, again, really emphasizing the importance of sharing our data for global benefit. And even though we have only half of the data, less than half the data openly available, there actually has been a lot of leadership in open data from satellite operating agencies. So in particular, in the United States in 2009, the Obama administration announced the Open Government Initiative, and part of that asked agencies to put their data up on data.gov. About a year after the program was in place, there were 5 agencies that were responsible for about 99% of the data up on data.gov, and among those 5 were the 3 satellite operating agencies in the United States. So NASA, NOAA with the weather satellites, and USGS with Landsat. And one of the reasons they were able to be leaders is that they were already making their data openly available. So when this program came along, they were able to very quickly kind of promote the fact that that data was up there. But it's not just a US phenomenon. There have been leaders in open data in other nations as well. So EUMETSAT, which operates the European weather satellites, made all of their archive data available online as of 1998. The China-Brazil Earth Resource Satellite Program started making their data freely available to users in Africa and in Brazil in the early 2000s, and then opened that up to everyone in about 2010. And then South Africa, also with their Sambandila-SAT, made that data openly available online after it was collected. And lots of other nations as well have some of their satellite data, at least some of their data, that's openly available online. So next I want to take you through a couple of case studies to show how these countries and how these agencies came to their open data sharing policies. So I'll start with NOAA, throughout the NOAA booth. So the very first Earth observation satellites that were ever launched were weather satellites. The weather community was very aware that this is going to be a very useful technology. They could look down at the Earth, see cloud cover across vast areas. And so the first satellites were weather satellites. And to really understand the value of these satellites and also keeping with norms of the global weather community, they made that data openly available. The weather satellites proved to be very useful, and so very quickly, within just a few years, they transitioned from a research activity that was run primarily by NASA to an operational activity, and something that we wanted to sustain for long periods of time. That led to a really significant increase in NOAA's budget that they needed to operate these satellite programs, and that caused Congress to say, okay, these are such expensive assets, what can we do to bring these costs down? And so Congress passed a law that allowed NOAA to charge commercial users for access to that data. And so NOAA did that, at least in some cases, for a period of time, kind of the early 90s especially. But then NOAA put out a report in the early 2000s saying that the revenues they were generating from these data sales were really quite low. And in fact, the revenue was so low that it might be less than the cost of actually running the system to accept payments. And so they really were advocating internally for a move to open data. They wanted to get that weather data out there. They didn't want to charge any users, even commercial users. And they were successful in doing that. So there's still a law in place that allows NOAA to charge, but NOAA over time has adopted more and more open practices and policies. And so now we're at a point today where NOAA's data really is fully openly available. And they are the leader in international cooperation and also looking now at cooperation with commercial entities. Next, I want to look at the Landsat program. So it's owned by the U.S. Geological Survey now, but it's kind of transitioned to different agencies over its lifetime. So the Landsat program was announced by Nixon at the United Nations in 1969. So just as the Apollo program is coming to an end, there's this idea that we're going to turn to Earth and really focus on the Earth. Landsat was going to be the first civil satellite to collect remote sensing imagery, right? So not just very broad cloud cover, but things we could actually see what's happening on the ground. Up until that point, it had only been done with reconnaissance satellites. And so one of the ideas with Nixon's announcement was to say, we're going to make this data available to the world, and so nobody needs to be concerned about the idea this data is out there, right? It's going to be available for everyone. And so when the very first Landsat satellite is launched, that data is made freely available. So NASA makes it available to researchers, operational users, and if you're just an individual who wants sort of a picture of your house from space, you can get that for a very small nominal fee. Landsat is so successful that Congress says, okay, there's so many applications, people are so interested in this data, maybe we can pass this off to the commercial sector, get it off the government books, and really start commercial remote sensing. And so they passed a law in 1984 to do that, and they signed a contract with a company called EOSat that is now going to run the Landsat program and sell the data from that satellite. So EOSat, from a commercial perspective, is somewhat successful. They actually do raise revenues over the period of time that they're running the program. But the distribution of the data goes down, so very few people are able to get access to the data at this time. It costs $4,400 for one Landsat image. After a number of years of trying this kind of privatization experiment, they decide it's really not, they're making some revenue, but it's not commercially viable. And so Congress passes another law in 1992, bringing Landsat back into government control. And when they do that, they make the data much less expensive. So now instead of $4,400 per scene, they bring it down to about $600 per scene. Still, that's a relatively high cost. And so I have USDA up here because they were a user of Landsat data, and in the early 2000s said, even at this couple $100 per scene, it's just too expensive for us, we're price sensitive, and they started buying imagery from one of the Indian remote sensing satellites and no longer use the Landsat imagery. So it was issues like that, and then also the fact that other countries, so Brazil in particular, started making their Earth observation satellite data freely available, that made USGS start to advocate, again from the inside, that we should move to an open data policy. And so they were successful in doing that. They did a pilot program for open data in 2007 and made it an operational program in 2008. And the distribution of the data skyrocketed. So you can see in the chart here, they went from a high of about 2,500 images distributed prior to the open data policy to a point where a couple years after they were distributing about 250,000 images a month. So a very dramatic increase in distribution. Okay, and lastly of the case studies here, here's NASA and NASA data sharing. So NASA really gets focused on the Earth at the very end of the Apollo program. And in fact, Administrator Fletcher went to Congress and said that it's possible to even think of NASA as an environmental agency, that the role of understanding Earth is so important in NASA's mission that's really a central aspect. And so they start something called the Mission to Planet Earth, which is going to involve a number of satellite missions that are going to focus on collecting data about the Earth as a holistic system. And they realize that data is a really key element. So in the early 1990s, as they're getting things ramped up for Mission to Planet Earth, they are going to spend about a third of their money on the data system, and they put in place an official data sharing policy that makes the data available to everyone possible. So at the time they put in place the policy, they were required by law not to give it for free to commercial users. When that law changed, they very quickly changed their data sharing policy. So as of about 1993, NASA data was completely free and open to everyone. NASA has also experimented with working with commercial entities. So one of the most interesting is the CWIFS programs in the early 2000s. So they came up with an agreement with a commercial entity where that commercial company would build the satellite, launch the satellite. They would be able to sell the data to commercial users within the first week. And after that, the data was available to NASA researchers, selected NASA researchers. And after 5 years, NASA could make all of that data, the archive data, openly available. They also did something called the scientific data purchase, where they also looked at buying data from the Iconos satellites and the other very new at the time, remote sensing satellites. But that program lasted about 5 years and then went away. Today, NASA is still making their data completely freely and openly available online. They have a lot of ways that you can access that. And one of the things they're really looking at now is as the volumes of data are getting extremely large. So they're looking at the NISAR satellite is going to bring in about 65 terabytes of data a day. So they're looking at a day, so they're looking at how they can make that data available, right? That's not something you can just download and use on your laptop. So one of the kind of key takeaways here, so with these agencies, I mentioned in the beginning, we have some leaders in open data, but also half the data that's not openly available. So why is that happening? Well, what we actually see, you saw in the kind of larger US agencies, they really move towards open data quite quickly. Where we're not seeing data shares in some of the smaller programs, so where they're developing satellites as capacity building projects or technology development, and the focus really isn't on the data. And it's very difficult to justify putting a lot of resources into building a data portal or a mechanism to get that data out to people. And also data that is kind of older or it's going to take a lot of work to bring it back up to the current technology and make it available to people. But in the agencies that have shared, a lot of times it's because they saw it as very central to their mission, right? You saw that with NASA, with NOAA, by making their data openly available, that's how they get the most science, that's how they get the most applications, and even the commercial value added sector. And so what's next in this area? Well, if we want to have more open data sharing, we need to do a good job of tracking how that data is being used. What is the demand for that data? How much value are we really getting out of putting that data out there? And then we want to share that information in these international forums, in groups like the Group on Earth Observations, so that really all these different agencies can understand what the value will be if they make their data available. And then also we need to prepare for these new challenges. So how do we partner with this exciting new wave of commercial remote sensing companies? How can we do that but still stay true to this open data sharing that we have? And then how do we leverage the cloud environment? We have these really large volumes of data. We still want to make them openly available, but we need to do it in a way that people can actually use the data and work with it. So those are the questions we need to deal with now.